You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
The Naked Scientist, Chris Smith, is back with us this week, and we've just opened our lines taking your science questions on any subject. Join us as we strip science down to its bare essentials. This is your opportunity to satisfy your curiosity about the world we live in and find out more about the weird and wonderful laws of nature and the intricacies of the human body. Dr. Chris will talk on the topic vaccine control HIV activity in monkeys. Hello, Dr. Chris.
Oh, good morning, Nfundo. How are you?
I'm very well.
Jolly good. So you want me to talk about this story?
Yes, about the vaccine control HIV activity in monkeys.
It's very interesting. It's a guy in the States called Dan Baruch, who I've spoken to a number of times because he's had a couple of papers about other viral infections that he's helping to solve earlier this year. But this one caught my eye because there are now something like 40 million people who are infected with HIV, and we're still running at maybe 2 million infections every single year, and we currently have no prospect for a vaccine. The gold standard way to control HIV is to administer antiretroviral drugs, ARVs, which suppress the growth of the agent, but they don't make it go away. And part of the problem is that when you first become infected with HIV, the virus establishes this reservoir of infection all around the body. It hides inside the DNA of immune cells all around the body. And so the minute you stop taking antiretroviral drugs, then the virus surges back from this reservoir and you see it again. So what scientists are wondering if it's possible to do is to turn people into much better controllers of the infection, if we can give their immune system a boost and see if you can suppress the virus. And what he's done using a group of monkeys which have a similar agent called SIV. It's an ancestor of HIV, but it behaves very similarly in monkeys to the way HIV behaves in humans. And he administered a virus, a modified form of the common cold virus called an adenovirus, which was also expressing a number of the proteins or markers made by HIV. And he gave this to monkeys which already had HIV and were receiving drug treatments for it. And then they stopped giving them their drug treatment. And in a third of the monkeys, after giving them this immune pep-up, the virus didn't come back in their bloodstream. In the other 2/3, it did come back, but at a much lower level, and it took a lot longer to do that. And so they're optimistic in this paper in Nature that this may be one way, or at least they're going down the right path, to strongly drive the immune system to encourage it to become better at controlling the virus, so that although you're not ridding the body of infection or stopping someone catching it in the first place, you are potentially meaning that a person doesn't have to depend on drug treatment, which has side effects. It's not ideal, it's also costly, and you have to have access to the drugs. It may be one way to help people who already have HIV to become much better controllers of the infection.
Wow. I think that's amazing to hear that there are some breakthroughs in these intractable diseases that the world has to suffer. Can I then just bring in a caller, Caroline Kenilworth? Can you please talk to Chris?
Hi, thank you very much, and you're doing a wonderful show today. Dr. Chris, I use a lot of eggs because I bake a lot, and I want to know why it is that some eggs have such a dark yolk and others have a very pale yolk.
Hello, Caroline. Well, the yolk of an egg is full of fat and cholesterol, and it's where most of the energy which will drive the development of the chick in its egg, because a chick has to sit in an egg for quite a long time and grow, and it needs a source of energy to help it to grow. So egg yolk contain a lot of fat and cholesterol, which is the energy/oil supply for that developing chick. Being as it is full of oil and cholesterol, things in the chicken that make the egg want to dissolve in oily things if they're oily themselves. Therefore, to a certain extent, oily chemicals in the diet of the chicken will naturally migrate into the egg yolk. And one of the chemicals in the yolk that makes it yellow are carotenoids, the yellow pigments that make carrots and have an orange colour. So
Okay.
chickens which are eating a diet rich in carotenoids or those sorts of molecules will naturally have a darker yolk. But also because the genes, the DNA makeup of the chicken, which is the chemical recipe book that tells the chicken how to operate, because that also dictates the biochemistry of the chicken, that to a certain extent will determine what the composition of the yolk is and how many of these coloured chemicals are in there. So therefore there is one, an element of diet and environment, what is the chicken eating, and number two, what is the genetic makeup of the chicken naturally, because that will also have an influence on the colour of its yolk.
Thank you so much. Bye.
Happy baking.
Thanks. We now have Mhlupeki from Tembisa.
Yeah, hi. I don't make it better.
Hello, go ahead.
Chris.
What can I talk to you about?
Okay, so yes, I'm Chris here, yeah. Well, I wanted to find out about the, how are you? Because it's not you, okay?
I'm sorry, the phone line is so bad I can't really hear you. Can you try and start again? Because we can't really understand you.
Yeah, I'm trying to stand on one place here, yes. Can you hear me now?
Well, I don't know. You're not saying anything. Go on, try the question again.
Okay.
Just speak nice and clearly and slowly and loudly, and we'll hopefully be able to understand you.
Okay, no, I just wanted to...
Oh, that line
No, it's
seems
gone.
to have
Never
dropped. Chris, I'll go forward to another caller from Brendan from Senton, who wants to talk to you.
Hello?
Fire
Hello?
away. Go for it.
Hello, Chris. I'm inquiring about this flat Earth conspiracy. And what I was actually wondering, you know, when they build a building like the Empire State or the Twin Towers, and they put a plumb line down, that technically, if we're on a curved horizon, why does the plumb line? Why would it stay straight? Why would it stay straight?
I'm not really sure of the myth conception or the controversy here, but the point is that if you live on a giant ball like the Earth, then the gravity that pulls your plumb line down towards the Earth points straight down towards the centre of mass, and the centre of mass of the Earth, being a curve, is right in the middle, and therefore your plumb line will form a straight line down towards the centre because it is like one of the radii of a circle or a sphere. Now, because the Earth is big and relatively large, this means that to your eye it does look flat, but in fact it's not. We can see that the Earth has a curved surface, and in fact the distance to the horizon, you can work it out mathematically. If you take the height of your eye in feet above the ground and you multiply that by, so you take the square root of that and multiply it by 1.24, that will give the distance to the horizon in miles. And you'll see that it's for an average person standing about their eyes about 6 feet above the ground, it's about a few miles off to the horizon. So to your eye, the Earth does look flat, but that's because the distances are large. If you were on a much smaller body, which was not quite so big, it would be more obvious that the surface were curved.
We take more of your calls for The Naked Scientist after this.
702 and Cape Talk.
The Naked Scientist.
The Naked Scientist, Dr. Chris Smith, is still online to answer your calls. Tony from Milnerton, what's in your mind and what do you want to ask?
Okay, good morning, Chris.
Morning.
I wondered if there'd been any advance in finding out what can help people like me who suffer from tinnitus. It's become quite, bad of late, and it's most disconcerting.
Yes, most people say that tinnitus is extremely distressing. And for people who don't know what tinnitus is, this is a ringing sound experienced in the ears in the absence of any sound input of that type. And it would appear to occur in people who have a degree of hearing damage, and particularly to certain frequencies in the audio spectrum, which can be because of past exposure to loud noises. There's also an age-related effect. As people become older, it becomes more common, and sometimes this can occur, or this damage can occur, because of drug treatment, and it can be exacerbated or made worse by certain drugs. Aspirin-like drugs can also make it worse sometimes if you take high doses of them. Now, we don't actually know why tinnitus happens, but some people say it's a bit like phantom limb syndrome. This is the pain experienced by people in their missing body part, such as a leg or arm, after it's been amputated. And you might say, well, why do you feel pain in a body part you no longer have? And the theory goes that the parts of the brain that decode sensation are continuously listening in to signals coming from every part of your body. And if they cease to receive signals from a certain part of the body, then the brain increases the gain. It turns up the volume of the listening system. And in the same way that if you turn up your radio when it's not tuned to a radio station and you hear hiss, if you turn the volume up, the hiss gets louder. And it's possible that you end up with the brain amplifying spurious, noisy signals that are nothing to do with real signals, but are coming from the missing body part. Now, the part of your ear that turns sound waves from the environment into brain waves that your brain can decode, the cochlea, it effectively, if you damage part of it, it becomes like a missing body part. And so one theory of tinnitus is that you actually are tuning in to the missing sound frequencies coming from your cochlea, and in the same way that you end up with phantom limb pain from a missing body part, you end up with phantom sounds coming from a missing cochlear part. And that's why you get these annoying sounds. One piece of advice that seems to work quite well is to say, do not tune into them. Try not to pay attention to them, because the more attention you pay to something, the more your brain optimizes its ability to experience it. And this makes it even more disconcerting. It is better, if you can, to attempt, A, not to become stressed by it, and B, not to focus or concentrate on it. And if you can, expose yourselves to some other soothing sounds which will help to take your brain's eye off the sonic ball for a bit, and you should begin to feel better. But unfortunately, at the moment, we have no magic bullet that will stop tinnitus, and it is a big problem, and you have my full sympathy for those people, including Tony, who've got it.
Thank you, Chris. And we now have Angie from Joburg online.
Hi, it's actually Panji with a P. The question I'd like to ask, if you fired Panji.
Sorry, sir.
Can I fly off with the question?
Yes. Yes, please go ahead.
If you fired a handgun standing on the moon's surface, what would happen? First, I'd like to know what would happen in terms of combustion. And secondly, if you stood against an object and you fired the handgun. And the third, if you jumped and fired a handgun at the same time, what would the three differences be?
Well, what you've effectively done there, Panji, is to actually repeat an experiment that Isaac Newton thought about. Isaac Newton being the famous physicist from Cambridge a few hundred years ago, who was the person who made us realise there must be gravity. Now, Newton's experiment was, he said, if I fire a gun along the Earth's surface, what happens to the bullet? He actually was thinking about a cannon. If you fire a cannonball, it's going to go out of the cannon and it's going to be experiencing a vertical force because of gravity down towards the ground. So after a certain distance and over time, the cannonball will fall gently and it will follow an arc down towards the Earth's surface. So then he said, well, if I fire the cannon a bit harder, I give the ball a bigger push, then what happens? Well, that time the cannonball goes further before it curves down and hits the Earth's surface. So then Newton said, well, if I fire the cannon really, really, really hard, what will happen then? And he realised that the cannonball would go out of the gun and it would fall towards the Earth's surface because of gravity. But then, because the Earth's surface is itself curved, the cannonball would be falling towards the Earth's surface at the same rate at which the Earth's surface is curving away from the cannonball. And this would mean the cannonball would always be falling towards the Earth, but the Earth would be falling out of the way. And you would have what we call an orbit, and that is exactly the physics that scientists and engineers use all the time to put satellites in space and other objects in space. It's why the moon goes round the Earth, it's why the Earth goes round the sun, and they don't all smash into each other. Now, the amount of force you have to give your cannonball in order to get it into orbit is therefore directly proportional to how hard the pull of gravity is. Therefore, if you fire the cannon on Earth, you need to give the cannonball a much bigger push because the Earth is more massive, it has more gravity. If you fired your gun on the Moon, the bullet would travel much further before it hit the ground because the Moon is much smaller than the Earth, therefore its gravity is less, therefore the bullet would be being pulled down at a slower rate than it would fall on the Earth, and therefore it would travel further before it landed. The other part of your question was, what would happen if you fired a gun on the Moon? Well, if you fired a gun on the Moon, the whole point of a bullet is that you have both the fuel and the oxidant in the bullet, which is what propels the bullet, so you don't need air to fire a gun. So the gun should go off on the Moon, assuming that the cold temperature of the Moon hadn't affected the gun, because it's pretty cold up there. The other question was, if you jumped and fired the gun, well, you would be above the ground and then fire the gun. I presume you're firing the gun horizontally. It would just mean the bullet went further. If you fired the gun vertically, then the gun would give you a push in the upward direction, which coupled with your jump in the upward direction would mean you would actually go higher up. You'd give yourself your own inbuilt rocket booster, I suppose you could say.
I'll now go to Louise in Stellenbosch. Louise, can you ask your question?
Hello. Good morning. Hello, Chris.
Hi.
I would like to know if microwaves actually kill the nutrients in vegetables. I love cooking in the microwave, but now I've stopped doing it because of that theory. Thanks. I will listen on the radio.
That's okay. The way in which a microwave oven works, the frequency of microwaves is about 2.5 gigahertz. That's 2.5 million cycles of light every second. It's a wavelength of about 12 centimetres. The reason that the manufacturers, inventors of microwaves chose that frequency of electromagnetic radiation is because it's really well absorbed by salty water, which food has a lot of inside it. And the way the microwave heats the food up is that it makes the water molecules jiggle backwards and forwards, and they try to move at the same rate as the microwave, about 2.5 billion times a second. And those vibrations are energy, and they transmit the energy into the food, and that makes the food get hot. Now, that's great, actually. It's a good way of heating things up. The downside of this is that because the microwaves are a wave, they have high and low points where there's lots of energy, and they have bits in the middle where there's no energy in the wave, or they're making the water molecules move at the least. And that means you get hot spots and cold spots in your food. And this means you must make sure you have a turntable in your microwave oven, because otherwise you will cook some bits of the food to death, and other bits of the food could remain virtually uncooked. Now, the downside of having areas that are real hot spots is that in those areas you could push the temperature way, way up transiently, and that could degrade things like the nutrients and the vitamins that are in the food. But you have to balance this idea with the fact that if I take my lovely vegetables and I dump them in a pot of nice hot water, and then I throw the water that they've been cooked in away, then what I end up with are vegetables from which all of the goodness has been leached into the water, and I've chucked all the goodness down the sink. On the other hand, if you were to turn that water that you've cooked your vegetables in into gravy for your meat, or you were to turn it into soup, you would conserve all of the goodness. So there are swings and roundabouts. There's no clear answer. I think in experiments I've seen that were not terribly objective, but they were a simple test, it suggests that actually microwaving food, especially vegetables, conserves more of the nutrients if you do it properly than if you have a big pan of hot water and you just dump your vegetables in there and then throw the water away.
Wow, thank you. And now we've got Aldred from Monte Vista.
Good morning, and thank you for taking my call. Good morning, Chris. Long time no speak.
Morning.
Chris, I listened with great interest on your story about the yolk of an egg. I would very much like to know what value has the white of the egg. I believe it supports the yolk from in suspension. It prevents shock getting to the yolk. I don't know how true that is. This is why I'm asking you the question. A friend of mine said that the white is actually the feathers. Is there any truth in this? And can you explain to me the value and the reason for the white of the egg? Thanks, Chris.
Right, no problem. I explained that the yolk is very fat-rich and contains a lot of energy. That's absolutely true. It does other things as well, but that's one important role. The white of the egg is the albumin, and this is the protein. And in order to make anything, our bodies are made, the structures, the materials we are made of, they're all proteins. Your hair, your nails, your eyes, the important things inside your cells that do chemical reactions called enzymes, they are all proteins. Proteins are made of amino acids, and they're all strung together in long strings, which make the proteins. You need a supply of that building block, the amino acids in proteins, in order to assemble tissues. And so the egg is effectively a storehouse with all of the things that a developing embryo needs in order to assemble a fully built chicken. And so you have fats and oils and cholesterol in the yolk, and you have a ready supply of protein, which is a bit like when the builder comes to your house and delivers a big pallet of bricks. And he dumps this big pallet of bricks on your driveway so you can then build your house with it. It's effectively giving you those bricks that you can dismantle the pallet of bricks and then build the bricks into what you want to make your house look like.
Thank you very much once again, Dr. Chris Smith. It has been very interesting, informative. For more about The Naked Science, you can visit his website at thenakedscientist.com. Right now on Cape Talk and 702, it's 10:30.